Okay, good day everyone. Welcome to this lesson on vector analysis. So in this lesson, we'll be discussing the curl of a vector and the Stokes theorem. So ano ba yung curl of a vector field and ano yung Stokes theorem? So yan ang pag-usapan natin in the next 10 slides ng aking presentation for today. So hopefully meron kayong matutunan dito sa lesson na to, no? Start na natin. From our previous video, we discussed or we defined yung gradient of a scalar and divergence of a vector. So, kung hindi nyo pa na uh, nadaanan yan sa playlist natin, ipopost ko na lang or puntahan nyo na lang doon sa playlist. So, yung gradient ng ating function, kung maaalala natin, is something like this, no? Del F, and then yung ating divergence naman is del dot F. So ngayon naman, we'll be discussing the curl. So ang kanyang, unahan ko na, ang kanyang notation is del cross F. No? So, yung gradient and yung divergence, they have physical meaning. And napakita natin na merong mga applications or may applications na yung dalawa na yon na pinakita natin. Okay? In particular, the divergence of a vector, pinakita natin to be an indication ng strength ng isang scalar source of a vector. Ngayon, ang question natin, if a vector can be generated by a scalar source, right, katulad nung sa divergence, is it also possible that a vector source gives rise to a vector field? Yan. Yan ang tanong natin sa video na to. Kung kung kaya natin, kung posible na ang scalar source is makapag-produce ng vector, kaya rin ba ng vector makapag-produce ng isa pang vector? Okay. Of course, ang sagot diyan is yes, no? So, makikita natin 'yan sa river or sa mga water water flow, no? For example, meron tayong river or water flow. Kunwari ito yung ating channel, sample lang 'to ha. Tapos meron tayong dumadaloy na tubig dito or fluid. Yan. Of course, 'pag may dumadaloy diyan na fluid, yung sa gitna, siya yung pinakamalakas na magnitude, siya yung pinakamabilis. And then habang lumalayo tayo sa center, lumiliit yung ating magnitude at saka bumabagal. Now, let us say na meron tayong ano diyan meron tayong velocity which is a vector, tama, quantity. So, ang characteristic ng flow natin is that sa gitna, siya yung maximum. Then, habang lumalapit siya sa pinaka-bank nung channel, humihina. So, tawag natin dyan is non-uniform velocity. Kumbaga, may variation dun sa flow ng velocity. Kung maglagay tayo, let's say, ng stick dito sa bandang gilid dito, yan, let's say, naglagay tayo ng stick dyan. And then, nilagay natin siya perpendicular dun sa flow. Kumbaga, iniharang natin yung stick doon. Ano sa tingin nyo yung mangyayari dun sa stick? Of course, dahil mas malakas yung nasa gitna, ang tendency ng stick ay itong side na to is magkaroon ng movement yan dito. At ito naman medyo maiiwanan, no? Magiging ganyan na siya, tatagilid. And of course, madadrag siya kasi mas mataas yung velocity doon kumpara doon sa iba. Itong behavior na to, yung um, magsasabi na ang tendency ng stick ay umikot, no? Dahil nga meron tayong variation sa velocity, ang tendency niya is itong end na to is gaganon, no? Or iikot siya. Ito naman susunod. Yan. So magkakaroon tayo ng circulation or rotation ng scalar source of the field. Okay? So although ang important point kasi dito is we cannot explain this rotation using scalar source of the field. So para mas maintindihan natin or ma-explain natin yung behavior na to, although alam natin mangyayari siya, dito natin ipapasok yung concept ng curl. Okay? So yung curl is related sa circulation and spatial variations in the vector field. So bago natin i-define yung curl, we must first define the circulation of a vector. Okay? So kung maaalala natin, no, circulation ng vector. So ito, introduction pa lang tayo ha. Wala pa tayo sa curl. Talaga, no? So, sabi natin dun sa pinag-aralan natin sa line integrals. Okay? We know that the circulation of a vector is equal to the closed, di ba? Closed contour integral ng vector na yan over a particular loop or length, no? Yan. And ang tawag kasi natin dito, di ba? Ang tawag natin dyan is circulation of vector field. Okay? Vector field around a contour. Contour. Okay? So, bakit nga ba natin tinatawagin na circulation? Para mas maintindihan natin, let us consider first a circular flow such as yung mga hurricane, no? 'Di ba? Yun yung mga hangin na ang paggalaw niya is paikot. Yung puwersa nun ng mga hurricane represents the work or energy expended. So this energy increases with the circulation. If we take this as a measure for a hurricane, then measuring the circulation would be a very good measurement ng strength ng hurricane na yun. So, ganun ka-importante itong curl, no? Again, ulitin lang natin that circulation implies that the line integral of a vector field along a closed contour. This circulation may or may not be zero, dun sa diniscuss natin, depending on the vector field, no, the contour, and the relation between the two. So, kung maaalala natin, yung pagsukat kasi ng circulation parang hindi siya ganun ka-convenient, di ba? Ang haba, integral. Isa pa, it gives an integrated value over the contour. Ang pinaka-importanting aspect ng field is makita natin or we want to physically measure any quantity associated with the flow. Okay? So, when measuring rotation, the direction and the plane of rotation, importante yan. These considerations lead directly to the definition of the curl. Okay? The curl is a vector of measure of circulation. Ulitin ko ha. The curl is a vector measure of circulation. It gives both the direction and the circulation of a vector per unit area of the field. So, para mas accurate, yan. Define natin yung curl. The curl of vector A is the circulation of vector A per unit area, as this area tends to zero and is in the direction normal to the area when the area is oriented such that the circulation is maximum. So mathematically speaking, okay, the curl down ng vector A is the circulation, no? Circulation ng vector A per unit area. Okay, per unit area, as this area tends to be zero and is in the direction normal to the area when the area is oriented such that the circulation is maximum. So yan ang definition ng curl. So mapapansin naman natin dito sa illustration na yan. So ito yung mga pula, yan yung ating curl. Ang tendency natin is umikot doon sa plane kung saan yung circulation is maximum. So pag 3D naman, ganito na may itsura niyan. Yan. So ito yung ating curl, no? Curl ng vector A. Okay, so meron tayong circulation. Yan. So ganun pa rin, gagamit pa rin tayo ng right hand rule to dictate kung saan yung direction ng curl. So in this case, yan, palabas siya, no? Kung saan maximum yung circulation. So yan. So of course, ito kasing notation natin ng curl or yung definition natin ng curl, mahirap nating i-apply yan, no? Kaya naman, ilista ko lang dito yung formulas na gagamitin natin to get the curl in terms of the vector. Kasi pag nililista natin yung vector, di ba? X, Y, and Z, Cartesian, cylindrical, and spherical. So, yung ating curl ng vector A, ito yung formula natin. Okay? The curl of vector A is equal to a particular vector, no? Sa Cartesian, meron tayong vector. Ganito yung formula natin. X hat times the difference ng partial derivative of A sub Z. So, itong A sub Z is the scalar component, diba? Sa Z direction. Pero with respect to Y, no? And minus the partial derivative naman ng A sub Y with respect to Z. So, tandaan lang natin yan, para mas maalala natin. So, yan tatlo kasi ikot-ikot lang yan. Okay. Para mas madali nyo matandaan yung pagsulat ng formula. Okay. So, X, tapos Y sa baba, Z sa taas. So, X, Y, Z. Tapos, yung kasamahan niya sa expression, pagkapalitin lang natin. So, kanina Z dito, ito naman Y, no? Yan. Ito naman sa baba yung Z. Okay? And then, plus, it is plus Y hat. So, ano naman yung nasa baba niya? So, X, Y, Z. Ang kasunod ng Y ay Z. Tsaka pala ang aakyat sa X. So, ganyan yan, ha? Laging X, Y, Z or Y, Z, X, Z, X, Y. Yung kanilang pagkakasunod-sunod. So, in this case, Y, Z, X. So, Z sa baba, X naman sa taas. Then, para makuha natin yung susunod na expression, that's minus, pagpalitin lang natin yung mga letra dyan. Okay? So, sa Z naman, so sa ilalim niya is X dahil ang kasunod na dito is X. No? Z, X, Y naman yan. Z, X, Y. Minus, palit. Okay? Palit naman. Yan. X naman yung nasa ibaba, Y naman yung nasa baba. Okay? Ganyan natin siya gagamitin or isusulat. So, kanina meron akong binabanggit na notation. Kung maaalala ninyo, ito yung ating del, no? Del. So, yung curl kasi is del cross ng A, kung vector A. So, gagamitin na natin yan ngayon. We define the curl of vector A denoted as, basa natin dito is del cross. Del cross A. Yan. Pero guys, hindi siya, hindi siya, this is not a cross product. Notation lang siya. Pakitandaan, no? Itong notation natin na to ay hindi po yan cross product. Yan ay notation lamang. Okay? So del cross A, which is the curl of vector A, is equal to this particular expression. Okay? So, hindi ko na yan uulitin pa. Pakitandaan nyo na kung paano natin yan isusulat. Meron pang mas madaling way para mas matandaan ulit natin yung itong curl ng A. So, we can rewrite this as an expression or using the determinant. So, in this case, no, the curl of vector A del cross A is equal to itong expression na to. Okay? Again, no, del cross A is also not a determinant. Hindi po yan determinant. No? Dahil yung ating ginamit dito is to rewrite lang para mas madali lang natin ma-solve yung itong expression na to. Okay? So, nirewrite lang natin siya as a determinant para mas madali natin maalala or hindi na natin kailangan magkabisado. No? Although, hindi talaga siya determinant dahil kung mapapansin ninyo, ito symbols to di ba? Partial derivative, partial derivative, partial derivative. Walang numbers dyan. So, pakitandaan lang na hindi siya determinant. No? So, unang-una, yung curl natin is not a vector product. Notation lang yan ng operation. And again, tandaan natin that the curl is not a determinant. Only that the determinant may be used to write this equation. So, of course, kung meron tayong Cartesian, hindi naman magpapahuli dyan yung cylindrical tsaka yung spherical. No? Meron din tayo dyan. Okay? So, kung ito yung ating expression ng Cartesian, yan, yung kanyang notation ay ganyan. Sa spherical naman, meron din, no? Ito naman. So, kung mapapansin natin dito, nag-introduce na tayo ng mga factors. Okay, factors dito sa R, meron yung 1 over R dyan. Pakitandaan na lang. Then, dito may 1 over R ulit. And then, sa A sub, I think this is okay. This is theta, no? Sorry. Or phi, rather. This is phi. Yan. R A sub phi. Okay. So, ganun pa rin, no? R phi then Z yung ating pagsulat. Yan. R phi Z tapos palit. Sa phi naman, Z phi ZR tapos palit din. Sa Z naman, ZR phi tapos palit. So, ganyan siya. Ito ay phi ha. Pakitandaan na lang. So, yung ating determinant or expression as determinant, ganyan siya. Yan. Mas madali itong tandaan. Gawa ng yung 1 over R, inilabas na natin, finactor out na natin. So, ang naiwan na lang sa loob na merong factor is yung itong A sub phi. No? Pakitandaan na lang na meron yan. Okay. So, pag sinolve natin itong determinant na to, using these expressions, ito yung lalabas. Okay. Yan. And of course, yung ating spherical, hindi rin yan pwede magpahuli. No? Mas malala yung spherical dahil yung kanyang del cross A, meron siyang 1 over R squared sin theta sa labas as kanyang factor. Then, meron pa mga factors dito sa ibabaw. R, may R sin theta, may R sa baba, R sin theta. Pakitandaan na lang yan, no? Buburahin ko yung mga para yan. Okay? Then, yung kanyang overall na or long cut, okay, is ito. Yan. Kailangan lang pakitandaan natin yan. Isulat na natin hanggat maaari. Kasi gagamitin natin yan later sa pag-solve ng mga examples. Okay? Medyo patagalin ko muna ng konti para makopya ninyo. Okay. So let's move on to the next slide. So now that we have proper definitions of the curl and the methods for evaluating it, so kailangan naman balikan natin ano ba yung physical meaning ng curl. Okay? So kailangan i-define natin or i-state natin ano yung mga properties ng curl. Okay? So these are the general properties ng curl ng isang vector. So number one, the curl of a vector field is also a vector field. So pakitandaan. So ibig sabihin ang result ng isang curl, pagkuha ng curl is a vector. So pag nakakuha kayo pag pinag-solve kayo ng curl at scalar quantity ang sagot ninyo, medyo magtaka na kayo. Okay? Bakit ganun? Next, the magnitude of the curl, gives the maximum circulation of the vector per unit area at a particular point. So pag pinahanap, determine the maximum circulation of the vector per unit area at this particular point, it refers to the magnitude of the curl. So ang gagawin niyo dyan is hanapin niyo muna yung curl and kukunin ninyo yung magnitude ng curl na yun. Okay? So yun yung maximum circulation ng particular vector per unit area. Third, the direction of the curl is along the normal to the area of the maximum circulation at a particular point. So, ito yan, nasa illustration yan. Kung nasaan yung maximum circulation at a particular point, yung direction is normal to that particular area. So, ito palang del cross A natin, or del cross A, is actually normal dun sa ating circulation, or yung ating plane. Maximum circulation. Okay? Next, the curl is distributive but not associative. No? Ano ibig sabihin yan? Ibig sabihin, hindi natin pwedeng i-distribute yung curl, no? Hindi siya pwedeng katulad nito, distribute natin dito, tapos distribute dun. Hindi siya ganun, no? Bawal yon. Pero, associative siya. Ano ibig sabihin yan? Ito, kunin natin yung curl ng A plus curl ng B, pwede siya, no? Pero hindi siya associative. Katulad nito. Hindi natin pwedeng ilipat tong parenthesis dito para masabi na same yon. Okay? So again, the curl is distributive but not associative. Okay? Next, the divergence of the curl of any vector function is identically 0. Ano ibig sabihin yan? So pag kinuha pala natin yung curl ng isang vector, let's say vector A, no, vector A, tapos kinuha natin yung curl, tapos kinuha pa natin yung divergence niyan, equal lang yan sa 0. Okay? Isa yan sa mga properties ng curl na merong gamit pagdating sa electromagnetism. Nadadaanan natin yan pag nandun na tayo sa topic ng na yan. Okay? Next property. The curl of the gradient of a scalar function is also identically 0 for any scalar. So, sabi kasi natin, di ba, pag kumukuha tayo ng gradient, ano ang result? Pag kumuha tayo ng gradient of a scalar function, ang result niyan ay vector. So, pag ginawa natin yung curl ng gradient ng isang scalar function, 0 din yan. No? 0 din siya. So, paano yan? Yan. So dito, meron tayong scalar quantity, kaya yung scalar hindi siya naka-bold, no? Medyo mahihain siya. So pag kinuha natin yung gradient to, tapos kinuha natin yung curl ng gradient na yan, equal yan dapat sa 0. So yan yung mga general properties ng curl na dapat nating tandaan when we are dealing with yung mga problems uh, related to curl. So, pakitandaan natin tong number 5 and number 6 kasi they are they play a very important role sa electromagnetics. And babalikan natin 'yan pagdating sa dulo ng ng chapter. Okay? So, to summarize bago tayo mag-solve ng mga kung ano-ano. To summarize yung discussion natin up to this point, pwede nating i-view yung curl as an indication kung merong rotation or circulation ang isang vector field at any point sa space. Hindi naman pwedeng sa z x-axis o y-axis at any given point in space. So, sabi rin natin, zero curl indicates, of course, no rotation pag zero yung curl. And vector field can be generated by scalar source alone. A general vector field with non-zero curl may only be generated by a scalar source. And the vector source, so ibig sabihin, pwede pala tayong makagawa ng vector field using a scalar source and a vector source. So nasagot na yung tanong natin kanina at the start of this video kung kaya natin maka-create ng vector field using a vector source. Okay? So may mga vector fields na merong zero divergence. Ibig sabihin ng zero divergence, right? Hindi siya sink, hindi rin siya source. And meron din mga vector fields na non-zero yung curl. So therefore, in this sense, the curl of a vector field is also an indication kung nasaan yung source ng field, right? Kaya lang, itong source na to is a vector source. So, magagamit natin yung curl, unang-una, as an indication na merong rotation and circulation yung ating vector field. We can also use the curl as an indication ng source ng particular field. And also, the curl is an indication of non-uniform flow. So, ibig sabihin, lumalabas kasi yung curl pag merong non-uniform flow. Whereas the divergence of the field only shows the scalar distribution of its sources. However, kailangan maingat tayo dyan sa idea ng rotation. Rotation in the field does not necessarily mean that the field itself is circular. May mga rotation na hindi naman circular. Pero it only means that the field causes a particular circulation. Okay? Katulad ng example natin kanina, di ba? Meron tayong water flow, tapos naglagay tayo ng stick, umikot yung stick dahil dun sa non-uniform flow. So, yun yung pinaka madali siguro na ma-visualize kung ano yung curl, di ba? Dahil madalas naman natin nakikita yung mga ganong phenomena sa nature. So, siguro let's try to solve examples of the curl. Okay? Yan. First example, or siguro isa lang to. Find the curl of vector A is equal to r hat 2 cosine theta minus theta hat 3r sine theta. So, unang tingin pa lang, no? Alam natin na nasa spherical coordinates tayo. So, we will apply the curl in spherical coordinates using yung formula na nandun kanina sa slide number 5 yata yan. So, sulat natin kahit na mahaba. No? So, yung ating del cross A, siguro sa R, isa-isahin na lang natin, no? Dun sa R component is equal to 1 over R sine ng theta times the partial derivative ng sine theta A sub phi Kahit ang sulat ko, no? Sorry with respect to theta. Minus 1 over r sine of theta ulit times the partial derivative naman ng a sub theta, no? Angat ulit natin to. A sub theta with respect to phi. So, substitute naman natin yung mga values na yan. So, paano na? So, partial derivative, no? 1 over r sine of theta times the partial derivative with respect to phi ng, oops, wala tayong component sa phi, no? Napakaswerte talaga natin, kaya 0 lang yan. 0 lang yan. Minus 1 over r sine ng theta times the partial derivative with respect to phi ng ito, laman nito. Diba? That's 3 r sine of theta. At napakaswerte na naman ulit natin. Dahil with respect to phi yan, lumalabas na wala namang feeding laman yan. So, alam naman natin na ang mangyayari dyan ay 0 lang din yan. Kaya naman, ang sagot natin dun sa first component natin is 0. Talaga namang napakaswerte natin. So next, sa theta naman, pula naman gamitin ka. Del cross A na nasa theta, it is equal daw yan sa 1 over r times 1 over sine ng theta times the partial derivative of a sub r with respect to phi minus the partial derivative of r a sub phi with respect to r. Okay? So, ngayon, yan naman ay equal sa 1 over r ulit. Kinokopya ko lang, no? Times 1 over sine ng theta. Ano yung partial derivative? Times the partial derivative ng, ano yung a sub r natin? That's 2 cosine theta. 2 cosine theta with respect to phi. Tama ba? Minus the partial derivative of quantity r times a sub phi. Napakaswerte na naman natin dahil yan ay 0. Okay? With respect to r. So, ayan. So, evaluate natin, ha. So, ito, mangyayari dito, partial derivative of 2 cosine theta with respect to phi. So, dahil swerte na naman tayo, dahil wala namang phi dyan, 0 na naman ulit yan, no? 0 yan. Tapos, partial derivative of r times 0, dahil 0 na yan, no, magiging 0 ulit ito. Okay? So, ang sagot natin will now be equal to 0. Okay. So, sa theta naman tayo. Gamit tayo ng green. So, del cross A ng component natin sa phi is equal daw yan sa 1 over r times the partial derivative of r a sub theta with respect to r, medyo pumapaling na yung sulat ko, minus partial derivative of a sub r with respect to theta. So, yun yung formula natin. Pagpasensyahan nyo na yung sulat ko. So, equal daw yan saan? That's 1 over r partial derivative with respect to r ng r a sub theta. Ito yung a sub theta ulit natin, right? 3r. So, magiging 3r squared na pala yan. Actually, negative pa yan. Sabray natin. Dahil meron tayong negative dyan, no? Ito rin, negative din to. Negative 3 r squared. No? R squared cosine theta. Yan. Tama, no? R sine pala, sorry. Bobo lang. Sine theta. Minus the partial derivative ng a sub r with respect to theta ng 2 cosine theta. Yan. So, ano mangyayari dito? Yung partial derivative ng negative 3r squared sine theta, ito yan, ito. No? So, meron yung value. Di ba? May makukuha tayo dyan. Which is equal yan saan daw? Sa negative 3 times 2r, yung kinuha na natin ng partial derivative, sine ng theta. Minus, partial derivative naman ng 2 cosine theta with respect to theta. So, meron din tayo makukuha dyan. That is actually magiging minus negative 2 sine of theta. Tama ba? Siyempre, tama. Kinokopya ko lang yan. So, ang sagot natin, equal na yan sa, so yung mga r natin, magka-cancel lang yan, no? So, ito lumalabas, negative 6 sine of theta. So, ito naman, magiging plus naman to, no? Plus 2 sine of theta. Therefore, yung ating curl ng vector A, syempre summation lang yan, no? Ng lahat ng yan. No? So, dahil 0 na yan, no? R hat 0 plus theta hat 0 plus phi hat times negative 4 sine ng, oops, ang pangit ng sulat ko, 4 sine of theta. Yan. And of course, dahil 0 naman to, di ba? 0, 0. So, dito ko na lang isusulat yung sagot natin. The curl of the vector A is now equal to negative phi hat 4 sine of theta. Okay? Yan. So, yun yung pag-solve ng curl. So, dapat vector quantity yung sagot natin. Kaya naman meron tayo ditong phi hat. So ganyan natin siya sasagutin. Okay? So next slide na siguro tayo ha. Describe naman natin tong ano ba tong Stokes theorem na 'to, okey. Ano ba yung importance niyan? So itong Stokes theorem, ito yung pangalawa sa theorem na diniscuss natin. So yung una 'di ba, diniscuss natin yung divergence theorem sa divergence. So ito naman yung pangalawa sa vector analysis na inintroduce natin. Very similar lang siya sa divergence pero it relates kasi naman yung curl ng isang vector sa line integral or sa correct, sa circulation ng vector. Okay? So ang sabi, the line integral of a vector field over a loop is equal to the flux of its curl through the enclosed surface. So meron tayong figure dito, no? Parang ang lumalabas kasi diyan, so meron tayong surface area, so lahat 'yan may mga maliliit na square, no? So lahat daw isa-sum down natin 'yan or i-integrate natin yung mga curl niyan. Integrate natin yung curl dun sa area ng lahat ng surface na 'yan. Equal naman daw 'yan dun sa ating tawag dito, line integral, no? Closed contour line integral. So, yan yung sinasabi ng Stokes theorem. Okay? So, ano bang gamit yung Stokes theorem na yan? Diba? Saan natin gagamitin yan? So, magagamit kasi natin yan para mapadali yung pag-solve natin ng mga circulation ng vector. Pangalawa, di ba diniscuss natin sa line integral, we can classify fields or vector fields into conservative and non-conservative. So, mas mapapadali yung pag-solve natin or pag-identify natin ng mga fields using curl instead of yung ating closed contour integral. Bakit? So, ang kailangan lang natin patunayan, so ang sinasabi kasi para masabi natin conservative yung ating vector field, dapat daw yung kanyang closed contour integral is equal to 0. So, yan ang magsasabi na conservative yung ating field over a particular surface. So, iba-ibang surface, iba-iba yung kanyang closed contour integral. So, para masabing conservative siya, dapat 0. And using Stokes theorem, no? Kung magiging 0 tong ating closed control integral, dapat 0 din yung right hand, no? Nung ating equation. Kung 0 to, dapat 0 din tong ating integral surface, the curl through the enclosed surface. The integral of the curl through the surface, dapat equal din yan sa 0 para masabi natin conservative. And by that alone, pwede natin masabi na kung ang curl natin ay 0, automatic magzi-0 to, di ba? So, kailangan lang pala nating patunayan is that the curl, hanapin natin yung curl, at kung yung curl na yon ay equal to 0, therefore, masasabi natin na yung ating vector field is conservative. Okay? Otherwise, so kung yung curl naman is non-zero, non-conservative yan. Okay? So, yun yung isa sa mga gamit ng Stokes theorem. Okay? So, let's try to solve particular problem. Okay, nasa slide number 8 na tayo. Last na to, then we'll wrap up na. So, find the contour integral. So, ito na, pinahanap sa atin yung contour integral of vector A on the upper half part surface of the sphere, x squared plus y squared plus z squared is equal to 4. It is above the xy plane, where the contour C is its boundary. Kumbaga, yung rim of the surface is in the xy plane. So, yung vector A natin is equal to x hat 2x minus y hat 2yz squared minus z hat 2zy squared. So, yan yung ating given. And of course, hindi natin yan isa-solve using the contour integral. Siyempre, yung topic natin is the curl, di ba? Kaya ang gagamitin natin solution is yung curl. Okay? So, para ma-solve natin yung ano na yan? Contour integral, no? Sabi, Diba? Contour integral of A, yan, equal dapat yan sa integral sa surface ng curl ng vector A. Yan. So, kailangan lang pala nating hanapin is itong curl, number 1, hanapin natin itong curl na yan. And then, i-evaluate natin yung curl na yan dun sa DS. So, okay. Yan. So, first, alamin muna natin yung mga component kasi 'di ba nasa XYZ tayo, ang formula ng curl natin is curl or V cross A is equal to uh, gamitin naman natin yung determinant para naman magamit. Yan. Tapos dito yung parang partial derivative with respect to X, partial derivative with respect to Y, partial derivative with respect to Z, tapos A sub X, A sub Y, A sub Z. Yan. So, ano ba yung A sub X natin? Di ba? Itong 2X minus Y yan. Tapos yung A sub Y, negative 2YZ squared. Tapos A sub Z is negative 2ZY squared. Okay? So, isa-solve na natin. Ang magiging sagot natin is X hat times the partial derivative daw. So, nandito na ako ha. Partial derivative with respect to Y ng A sub Z. A sub Z is negative 2ZY squared minus the partial derivative, ito na yun, the partial derivative naman ng with respect to Z, so pagbabalik rin natin ng A sub Y. Ano yung A sub Y natin? Negative 2YZ squared. Yan. Plus Y hat. Sa Y hat naman, partial derivative with respect to Z, ng ating A sub X. Ano ba A sub X natin? 2X minus Y. Okay? Minus the partial derivative with respect to X ng ating A sub Z. No? That's negative 2ZY squared. Okay? Yan. Plus Z hat times the partial derivative with respect to X ng A sub Y. Ano yung A sub Y? Negative 2YZ squared minus the partial derivative with respect to Y ng ating A sub X, which is 2X minus Y. Woo! Okay, so solve na natin to, no? So, simplify natin. Equal yan sa, so, partial derivative with respect to Y, magiging X hat. So, ito, magiging negative 4, no? Negative 4 ZY. Minus, no? Magiging minus, negative 4 ulit, negative 4, ZY ulit pala yan, no? Plus, Y hat, dito na naman tayo, with respect to Z ops, walang Z yan, so 0, minus, partial derivative nito with respect to X, 0 ulit yan, plus, Z hat, ito naman, partial derivative ng negative 2YZ squared with respect to X, pagandahan dyan 0 yan dahil wala namang X, minus the partial derivative with respect to Y ng 2X minus Y, which is, so, minus negative 1. No? Yan. So, ang sagot pala natin sa contour, sa curl ng vector A is equal to Z 1. Kasi ito nag-cancel na tayo diyan. Ito 0 naman 'yan. Tapos ito naging positive, no? Naging positive 1 'yan. Okay? So, di pa tayo diyan tapos, no? So now, we can now write the integral ng ating function. Okay? So, ang sabi kasi, yung ating integral nasa half part surface ng ating sphere. X squared plus y squared plus c squared is equal to 4. So, dito pa lang malalaman natin na yung ating boundary or yung ating you call this, limits is nasa spherical coordinates. Kaya, kailangan i-convert muna natin yan lahat sa spherical bago natin yan ma-solve. Okay? So, siguro simulan natin dito. Okay? So, ito pala, no? Dito na natin simulan. May dot to, ha? May dot. Surface ng ating okay, z hat na, no? Z hat dot, ano yung ds natin sa spherical? We have r squared sine theta dr or d theta kasi nasa r eh. D theta d phi. Okay? So dahil nasa z direction naman siya. So yun yung ating gagamiting dz. Okay? So it is now equal to, yung r squared pwede nating alisin yan, no? Kalimutan ko yung ating r theta, no? R hat. Yan. Ngayon magiging equal yan sa r squared times the surface integral ng z hat cross r hat ng sine theta d theta d phi. Yan. So ano ba ang cross product nitong dalawa na to, ng z tsaka ng r? So kung maaalala natin, ang cross product ng dalawa na yan ay actually cosine theta. Therefore, ang equation natin magiging r squared times the surface integral ng cosine theta sine theta d theta d. So, meron tayong dalawang variable, d theta and d phi, right? So, ano yung ating limits? So, sabi, ang limits natin sa spherical, no? O sphere, yung ating theta o yung ating phi yan ay manggagaling sa 0 hanggang 2 pi. Okay? So, kasi half part surface, no? Kung ito yung ating bilog, so simula dito hanggang paikot, no? Paikot. So, paikot siya. Yan. So, 0 to 2 pi yan. Pero yung ating theta, that would be from 0 hanggang pi over 2. No? So, yan. So, 0 hanggang pi over 2. Bakit ang sulat ko? So, sagutan na natin. The closed contour integral ng a dot dl equal pala yan sa integral ng ating phi is equal to 0 hanggang 2 pi times the integral ng ating theta from 0 to pi over 2 ng cosine theta sine theta d theta d phi. Okay? So, paano natin yan i-evaluate? So, huwag natin kalimutan guys, merong r squared dyan ha. R squared. Okay? So, equal yan sa, so, sagutan muna natin siguro yung d phi kasi phi lang naman yan, no? Wala naman siya ibang kasama. So, ang matitira lang sa atin dyan is r squared times the integral ng theta from 0 to pi over 2 ng phi evaluated from 0 to 2 pi. Yan. Cosine theta sine theta d theta. Okay? And ito magiging 2 pi lang to, no? And then yung r natin, ang r kasi natin is actually equal to sa 2. Kaya ang mangyayari na dyan, it is now equal to 2 squared times 2 pi minus 0 times the integral from 0 to pi over 2 ng identities natin is 1, identity, no? Sulat ko, pulahan natin. 1/2 sine of 2 theta. Mahaba. D theta. Okay? Tandaan nyo na lang yung mga trigonometric identities natin. So, ang sagot na natin dyan, ang final answer natin, magiging equal yan sa 4 pi. Okay? So, the contour integral of vector A dito sa problem na to for vector A is equal to 4 pi. Okay? So, ganyan tayo mag-solve ng paggamit ng curl sa mga problems. Okay? So, that's it for this particular lesson. I hope meron kayong natutunan. And, sinamarize ko naman na yung lesson kanina before tayo mag-solve ng problem. So, you may want to go back sa mga formulas natin ng curl and kung paano natin gagamitin yung Stokes theorem sa mga problems. Ayun. Maraming salamat sa pakikinig and panoorin niyo yung iba nating mga videos sa vector analysis. And sundan pa natin yan ng mga ibang identities with regards dun sa differentiation ng mga vector fields. Okay, again, yung ating gradient of ang notation natin is del F. Divergence is del dot F. And yung ating curl is del cross F. Okay? So, yung dalawa is dapat bold kasi diyan ay vector quantities. Kasi ito naman ay scalar. Okay? Ito naman ay vector. So, that's it. Maraming salamat. Keep safe and see you on the next lesson.